Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will use trigonometry to solve problems. So the problem I'm going to solve involves bearings, so I'll just give a quick crash course in bearings. So the idea behind the need for bearings is this. Let's say we start here at this point and it's Canberra. Let's say I ask a pilot to fly to Sydney. Well, we know to go from Canberra to Sydney, you have to go northeast. But you know to go from Canberra to Brisbane is also northeast. So if I tell a pilot to start here and go northeast, how do they know whether to go in this direction or they go up here? How do I ensure they go to Sydney and not Brisbane? Well, the way we get around that, the way we get around the ambiguity is we give each direction a number, an angle. So it turns out to go from Canberra to Brisbane, the bearing's around 23 degrees. To go from Canberra to Sydney, the bearing is about 50 degrees. So giving these numbers gets rid of the ambiguity of just saying go northeast. I know to travel on this path at 50 degrees, I'll end up in Sydney. To travel at this path on 23 degrees, I'll end up at Brisbane. So to avoid the ambiguity, we give each direction an angled number between 0 and 360 degrees. 0 degrees is due north, 90 degrees due east, 180 due south, 270 due west. So if the bearing I give you is, say, between 270 and 360, it'll be in this quadrant. Between 180 and 270, it'll be in the southwest quadrant. Between 90 and 180, it will be in the southeast quadrant, and so on. The bearing, the angle, the number I give is always the angle made with the north-south axis in a clockwise direction. So always the angle made with this axis going in a clockwise direction. So if we had a bearing out here and this angle was 23 degrees, we wouldn't label this bearing 23 degrees because this bearing to Brisbane is 23 degrees, and that would just be ambiguous. So what we do is we don't look at this angle, instead we look at this angle, north-south axis going in a clockwise direction. So if this angle here were 23 degrees, this angle in yellow would be 270 minus 23, which is 247 degrees. That would be the bearing in this direction. All right, let's now use some trigonometry to solve a problem. So let's look at this question here. Two hikers set out from the same point. James for 8 kilometers on a bearing of 190. Daniel for 5 kilometers on a bearing of 70. Hikers are now this far apart, and we want to find the bearing from James to Daniel. So if you're not given one, let's start by drawing a diagram. So let's let this be the starting point. So James went on a bearing of 190 degrees. So due south is 180 degrees. So James went over here on a bearing of 190. This angle would be 10 degrees. So Daniel, on the other hand, went on a bearing of 70 degrees. So that's up here and in the northeast quadrant. So due east is 90 degrees. So he would have gone in this direction, and this angle there would be 20 degrees. So we're also told that the distance from James to Daniel, that distance there is 11.36 kilometers. So what we want to do is find the bearing from James here to Daniel there. So let's draw a compass at James. What we want to do is we want to find this angle in here, because the bearing is the angle made with the north axis going in a clockwise direction. So we can make a right-angled triangle here because clearly east and south are 90 degrees to each other. So if this angle here is 10, this angle here is also 10 because they're alternate. What I need to do is find this angle here. I need to find the angle in here that's part of the triangle, because this angle I've colored blue plus 10 degrees will give me the bearing. Now I have a triangle here with all three sides, so I can find this blue angle here pretty easily using the cosine rule. So we have theta, this angle in blue I've called theta, equals cos inverse of a squared plus b squared minus c squared over 2ab. So remember, when you're using the cosine rule to find an angle, the side that's subtracted is the one opposite the angle you're trying to find, and it's the side that doesn't appear in the bottom. So putting this on my calculator, I get about 22.4 degrees. So the total bearing from James to Daniel, this angle in here, is 10 plus 22.4, which is about 32.4 degrees. So if James wanted to go from here to meet up with Daniel, he would need to travel this 11.36 kilometers on a bearing of 32.4 degrees. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.